Welcome. Today we're diving into the world of electrical circuits with a focus on Kirchhoff's laws. These laws are fundamental tools for analyzing complex circuits, allowing us to understand how current and voltage behave in different parts of a circuit. Whether you're a student, an enthusiast, or just curious about electricity, this video will break down the essentials and show you how to apply these laws in simple, practical scenarios. Let's start by exploring what Kirchhoff's laws are and why they're so important in electrical engineering and physics. Kirchhoff's laws consist of two main principles: Kirchhoff's current law KCL and Kirchhoff's voltage law KVL. KCL deals with the flow of electric current at a junction, while KVL focuses on the sum of voltages around a closed loop. These laws were formulated by Gustav Kirchhoff in the 19th century and remain essential for circuit analysis today. Understanding these laws helps us solve for unknown currents and voltages in circuits that might seem complicated at first glance. Let's begin with Kirchhoff's current law, often abbreviated as KCL. This law states that the total current entering a junction in a circuit is equal to the total current leaving that junction. In other words, electric charge is conserved at every point in a circuit. This principle is incredibly useful when analyzing circuits with multiple branches, as it allows us to set up equations based on the currents flowing in and out of a node. Next, we have Kirchhoff's voltage law, or KVL. This law tells us that the sum of all voltages around any closed loop in a circuit must be zero. This includes the voltages across batteries, resistors, and any other components. KVL is based on the conservation of energy, ensuring that the energy supplied by sources is fully used up by the circuit elements as we travel around a loop. Kirchhoff's laws are the backbone of circuit analysis. They allow us to analyze circuits that are too complex for simple series and parallel rules. By applying KCL and KVL, we can solve for unknown currents and voltages, design new circuits, and troubleshoot existing ones. These laws are used in everything from household wiring to advanced electronics and are essential knowledge for anyone working with electricity. Let's look at a simple circuit example to see how Kirchhoff's laws work in practice. Imagine a circuit with a battery and two resistors connected in series. We can use KVL to write an equation for the voltages around the loop, and KCL to confirm that the current is the same at every point in a series circuit. This basic setup is a great starting point for understanding how these laws are applied. Series circuit, Kirchhoff's voltage law tells us that the sum of the voltage drops across each resistor equals the total voltage supplied by the battery. For example, if the battery provides 9 volts and there are two resistors, the voltage drops across them must add up to 9 volts. This allows us to calculate unknown voltages if we know the values of the resistors and the total voltage. Now let's consider a parallel circuit where two resistors are connected side by side to a battery. In this setup, KCL is especially useful. At the junction where the current splits, the total current from the battery divides between the two branches. By applying KCL, we can determine how much current flows through each resistor based on their resistance values. Parallel circuits, Kirchhoff's current law helps us understand how current divides at a node. The sum of the currents entering the junction equals the sum of the currents leaving. If the total current from the battery is known and one branch's current is measured, we can easily find the current in the other branch using KCL. This is crucial for designing circuits with multiple devices operating simultaneously. Any real-world circuits combine series and parallel elements. By applying both KCL and KVL, we can analyze these more complex circuits. For example, a circuit might have a series connection feeding into two parallel branches. Using Kirchhoff's laws, we can write equations for each loop and junction, making it possible to solve for all unknown currents and voltages. In analyzing a circuit, the first step is to label all currents and voltages. Then, use KCL at each junction and KVL for each loop to set up a system of equations. These equations can be solved using algebra to find the unknown values. This systematic approach is the foundation of circuit analysis and is used by engineers and students alike. Let's walk through a two-loop circuit example. Suppose we have a circuit with two loops sharing a resistor. By applying KVL to each loop and KCL at the junctions, we can write equations for the currents in each branch. Solving these equations gives us the current through each resistor and the voltage drops across them. This method is widely used in practical circuit analysis. Once the equations are set up, we can use substitution or matrix methods to solve for the unknowns. For simple circuits, substitution is usually enough. For more complex circuits, matrix methods or computer software might be used. The important thing is to follow the logical steps provided by Kirchhoff's laws to ensure accuracy in your results. Kirchhoff's laws aren't just for textbooks, they're used in real life too. For example, home wiring systems rely on these laws to ensure that current is distributed safely and efficiently. Electricians use KCL and KVL to design circuits that power lights, appliances, and outlets, making sure everything works together without overloading any part of the system. When something goes wrong in a circuit, Kirchhoff's laws are invaluable for troubleshooting. By measuring currents and voltages and comparing them to expected values from your equations, you can pinpoint where a problem might be, like a broken wire or a faulty component. This systematic approach saves time and ensures safety. Multimeter is a handy tool for measuring current and voltage in a circuit. By applying Kirchhoff's laws, you can interpret these measurements to check if your circuit is working as intended. For example, if the sum of measured voltages around a loop doesn't add up to zero, there may be a problem that needs fixing. Kirchhoff's laws are based on fundamental conservation laws, conservation of charge for KCL and conservation of energy for KVL. These principles are universal in physics and ensure that our circuit analysis is grounded in real-world behavior. Understanding these foundations helps deepen your grasp of how circuits operate. While Kirchhoff's laws are powerful, they have limitations. They assume that the circuit elements are lumped and that electromagnetic effects like capacitance and inductance are negligible. In high-frequency or very large circuits, more advanced analysis methods may be needed. However, for most practical circuits, Kirchhoff's laws work perfectly. Gustav Kirchhoff, a German physicist, introduced these laws in 1845. His work laid the foundation for modern circuit theory and has influenced generations of scientists and engineers. Today, Kirchhoff's laws are taught in classrooms around the world and remain a key part of electrical engineering education. In working with circuits, it's important to use standard symbols and notation. Resistors, batteries, and other components each have their own symbols. Currents are usually labeled with arrows and voltages are marked between 2 points. Clear diagrams help avoid confusion and make applying Kirchhoff's laws much easier. Here are some tips for applying Kirchhoff's laws. Always label all currents and voltages clearly. Choose a consistent direction for current flow. Even if you're not sure which way it actually goes, the math will sort it out. Double-check your equations for each loop and junction and don't forget to include all sources and drops. Some common mistakes when using Kirchhoff's laws include forgetting to include all elements in a loop, mixing up current directions, or missing a junction in KCL. Careful diagramming and systematic equation writing help avoid these pitfalls. Practice makes perfect, so don't get discouraged if it takes a few tries to get it right. After solving for currents and voltages, it's always a good idea to check your work. Plug your answers back into the original equations to make sure everything adds up. If something doesn't match, retrace your steps and look for calculation errors or missed components. Kirchhoff's laws are also used in more advanced applications, such as analyzing circuits with capacitors and inductors or in AC circuits. While the basic principles remain the same, additional considerations like phase differences and reactance come into play. These topics build on the foundation provided by KCL and KVL. In electronics, Kirchhoff's laws are used to design and analyze everything from simple LED circuits to complex microprocessors. Engineers rely on these laws to ensure that devices function correctly and efficiently. Whether you're building a robot or a radio, understanding Kirchhoff's laws is essential. Today, many engineers use simulation software to model circuits and apply Kirchhoff's laws virtually. These tools allow for quick testing and troubleshooting before building physical prototypes. However, a solid understanding of the underlying laws is still necessary to interpret the results and make informed design decisions. In a typical physics lab, students might build a simple circuit and use Kirchhoff's laws to predict and measure currents and voltages. By comparing theoretical calculations with actual measurements, students gain hands-on experience and a deeper understanding of how these laws work in practice. Professional circuit designers use Kirchhoff's laws every day. Whether designing power supplies, audio equipment, or communication devices, these laws help ensure that circuits operate safely and efficiently. Mastery of KCL and KVL is a key skill for anyone pursuing a career in electronics or electrical engineering. Safety is a top priority when working with electricity. Kirchhoff's laws help ensure that circuits are designed to handle the expected currents and voltages, reducing the risk of overheating or electrical fires. Always follow safety guidelines and double-check your calculations before powering up a new circuit. Renewable energy systems like solar panels and wind turbines also rely on Kirchhoff's laws for circuit design and analysis. These systems often involve complex networks of batteries, inverters, and loads. Applying KCL and KVL ensures that energy is distributed efficiently and safely throughout the system. Modern vehicles contain intricate electrical systems, from lighting to infotainment to engine control. Kirchhoff's laws are used to design and troubleshoot these systems, ensuring that each component receives the correct voltage and current. This keeps vehicles running smoothly and safely. Communication devices, such as radios and smartphones, depend on precise circuit analysis. Kirchhoff's laws help engineers design circuits that transmit and receive signals reliably. Accurate current and voltage calculations are essential for clear communication and device performance. Large-scale power distribution networks like those that supply electricity to cities are analyzed using Kirchhoff's laws. Engineers use these laws to balance loads, prevent outages, and ensure efficient delivery of electricity from power plants to homes and businesses. Robots rely on electrical circuits for movement, sensing, and control. Kirchhoff's laws are used to design the power and signal circuits that make robots function. Whether it's a simple line-following robot or a complex industrial machine, these laws are at the heart of robotic electronics. Medical devices, such as ECG machines and pacemakers, require precise electrical control. Kirchhoff's laws ensure that these devices operate safely and effectively, delivering the right amount of current and voltage to sensitive components. This is critical for patient safety and device reliability. Researchers use Kirchhoff's laws to design experiments and analyze data in fields ranging from physics to chemistry to biology. Accurate circuit analysis is essential for collecting reliable data and making new discoveries. These laws provide a universal framework for understanding electrical systems. Environmental monitoring systems often use electrical circuits to collect and transmit data from sensors. Kirchhoff's laws help ensure that these circuits operate reliably in remote or harsh conditions, supporting efforts to track pollution, weather, and wildlife. Many educational tools and online simulations use Kirchhoff's laws to teach students about circuits. Interactive platforms allow learners to build virtual circuits, apply KCL and KVL, and see the results instantly. This hands-on approach makes learning about electricity engaging and effective. To recap, Kirchhoff's laws are essential tools for analyzing electrical circuits. KCL deals with current at junctions, while KVL focuses on voltages in loops. By applying these laws, we can solve for unknowns, design safe and efficient circuits, and troubleshoot problems in a wide range of applications. The best way to master Kirchhoff's laws is through practice. Try solving a variety of circuit problems, starting with simple series and parallel circuits and moving on to more complex networks. Each problem you solve will strengthen your understanding and build your confidence. There are many resources available for learning more about Kirchhoff's laws, including textbooks, online courses, and interactive simulations. Exploring these materials can help deepen your understanding and prepare you for more advanced studies in electronics and electrical engineering. Many engineers and inventors have used Kirchhoff's laws to create groundbreaking technologies. From early telegraphs to modern smartphones, these laws have played a crucial role in shaping our world. Learning about their applications can inspire you to tackle your own projects and innovations. Let's review what we've covered: the basics of Kirchhoff's current and voltage laws, how to apply them, and their importance in real-world applications. Remember, practice and careful analysis are key to mastering circuit analysis. Keep exploring and applying these concepts in your studies and projects. Don't be intimidated by complex circuits. With Kirchhoff's laws and a systematic approach, you can tackle even the most challenging problems. Stay curious, keep practicing, and remember that every expert started as a beginner. Your understanding will grow with each new problem you solve. Thank you for joining this journey through Kirchhoff's laws and their applications. We hope you now feel more confident in analyzing circuits and understanding how electricity flows. Continue exploring, practicing, and applying these principles, and you'll be well on your way to mastering circuit analysis.